So chapter 14, that gets into the peripheral nervous system. If you remember, when we break up our nervous system, we break it into two parts, our central nervous system and our peripheral nervous system. Central nervous system consists of your brain and your spine, no cord. And then we had all those different divisions of your brain and all those different divisions of your spinal cord. Okay, now we're getting into the peripheral nervous system. Peripheral nervous system, we break that into somatic and visceral. The visceral part, we break that into sensory and motor. And then motor gets broken into sympathetic and parasympathetic. And we'll talk about all of those kind of as we go. But right now we are starting right about here. Your peripheral nervous system is functionally divided into your sensory and motor divisions. Sensory input and motor output is divided into somatic and visceral, and then general and special. I mean, it's both actually. You have somatic sensory, somatic motor, and you have general sensory, all that kind of stuff, okay? The nerves of the peripheral nervous system will allow the central nervous system to receive information, initiate action, do all of the things that we need to do to eventually get back to homeostasis. Usually, your body's goal is to get back into homeostasis. Okay. Peripheral nervous system, like I had stated, the general visceral motor portion of your peripheral nervous system is the autonomic nervous system. And as we know, the autonomic nervous system is the one that is handled automatically, which means that we do not control it voluntarily. It is under involuntary control. Okay. And then that autonomic nervous system is broken into two parts, the sympathetic and the parasympathetic. And we're going to get into details about both of those systems soon. Okay. There it is. There's that breakdown. Peripheral nervous system gets broken into sensory and motor. We have somatic and autonomic. Then autonomic is broken into sympathetic, parasympathetic. Let's go back a second. All right. So how do we organize the peripheral nervous system? Essentially, it's organized into its respective pieces. The sensory receptors are going to be the guys that pick up stimuli from inside or outside of the body, right? Your peripheral nervous system's one of its many jobs, I will say, is to perceive stimuli around, inside, outside the body send that up to the central nervous system so that it can get processed and integrated so that we can do something about whatever the stimuli is. Okay, so you have those sensory receptors, you have nerves and ganglia. Nerves are just bundles of peripheral axons, right? Just a bunch of axons running in the same direction. And then a ganglia is a bunch of neuronal cell bodies in one area. Cell body, cell body, cell body, cell body. And then the nerves can kind of go off where they go. Right? And then motor endings are just the axon terminals of motor neurons, and they are going to innervate your effectors. Your effectors are going to be the muscles, glands, whatever, that are going to do something about whatever is going on in your body. That's a muscle. Uh-oh. What did Brian do? Cool? Cool. Great. So, those sensory receptors, we have to classify them some way, somehow. And we classify them in kind of three different ways. Two really, and then the two gets kind of broken down. One, their function, and two, their structure. And within their function, we can kind of break them down by their location, where we might find them, and then the type of stimulus that they detect. There are different type of receptors that will find different things throughout your body. And then the structure of those receptors was also one of the ways that we kind of delineate what is what. Okay? An exteroreceptor, you see this exter, right? What does that kind of sound like? Exterior, exit, outside, exterior. Those receptors are going to be sensitive to stimuli that show up outside of the body. Okay? They're going to include receptors for touch, pain, pressure, temperature, all kinds of stuff. It's a little chilly in here, right? That's because your thermoreceptors are aware of the fact that this room is cold. But if you walk outside and you stand in the sun, I know that when I was standing in the sun for like 10 seconds flat, I was starting to get kind of warm because it's like 90 degrees today. My thermoreceptors that are on near my skin are responding to that heat. Okay? Interoreceptors, they receive stimuli from internal viscera. So you're going to find those in your digestive tract, your bladder, your lungs, things like that. Okay? And they're going to monitor a lot of the goings on of your internal body. So like changes in chemical concentration, tasting things, your tissues stretching, temperature. Your internal organs have temperature and they need to be relatively regulated, right? Have you ever drank a ice cold glass of water and you can kind of feel that the cold water slide down your esophagus until it kind of hits your stomach, and then you're like, whoa, that's a different temperature than the rest of my body. That's because you have thermoreceptors internally to monitor that kind of stuff. Okay? And then proprioceptors, you're going to find them in your skeletal muscle, your tendons, joints, and ligaments, and they help you monitor the degree of stretch. Bless you. Okay? So proprioceptors help you to kind of determine how body is moving. Okay? Right? When you are doing yoga or whatever it is that the people do, when you're doing one of those little leggy stretches and it starts to hurt, right? You're trying to pull your toes back and it starts to hurt. That's your proprioceptors telling you, hey, this muscle, this tendon, this ligament, it doesn't stretch any more than that. You got to work on your flexibility, my guy. Okay? So there's those proprioceptors. help you kind of determine how your body is moving and to what extent your body is moving. Cool? So those are based on location, outside, body. That says boy. Inside, body. And moving body. Cool? Sick. We can also classify them based on what type of stimulus they respond to. Okay? Mechanoreceptors are going to respond to mechanical forces, things like touch, pressure, stretch, vibration, itchiness. These are all mechanical forces, right? When your phone vibrates in your pocket, you can feel that, right? That is a mechanical receptor that is saying, hey, something's buzzing, something is shaking. Okay? Baroreceptors are a specific type of mechanoreceptor, and they monitor your blood pressure. Usually you're going to find those baroreceptors in your carotid artery. But you can also find them in other places. Thermoreceptors respond to changes in temperature. You can find thermoreceptors all over the place. Inside your body, outside your body. They can be classified as both intero and exteroreceptors, all kinds of stuff. Chemoreceptors respond to changes in the chemical solution. So let's say I decided to chug a bunch of salt. I just was having a real salty day and I just wanted to, I don't know, do some lines of salt for some reason. When I do all those salt, when I drink all that salt or eat all that salt, it will change the composition of sodium in my body. That change of sodium composition can affect my cells. There's a lot going on with your sodium, potassium pump, stuff like that, blah, 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 blah. Not going to get into it. That's a physio problem, okay? Photoreceptors respond to light. They are going to be mostly in your eyeballs. I don't think there's anywhere else in your body that can respond to light per se. Okay? And then nociceptors are receptors that respond to pain. You have specific receptors that respond to painful stimuli. So all those times that, I don't know, what was the thing that I did recently? Oh, dude, I absolutely smashed my finger in a door. My nociceptors were screaming. They were not happy with me. Cool? Sick. You can also classify them by structure. And by structure, I don't like having this slide first, but it is here. Your general sensory receptors are going to be kind of everywhere, all throughout your body. And those nerve endings of those sensory neurons are going to monitor all of these things. But if we're talking their actual structures, these general sensory receptors are divided into two groups. The first are free nerve endings. The second are encapsulated nerve endings. And then free nerve endings, there are two specialized types of free nerve endings. We have these epithelial tactile complexes, also known as Merkel discs. Those Merkel discs are slow adapting receptors for light touch. Okay. So they can kind of understand, feel, be with light touch. And then hair follicle receptors, those are going to wrap around your hair follicles, and those are rapidly adapting. They're really, really good at knowing when they've been touched. That's part of why you can feel like an ant crawling on you, right? If it passes one of your like hair follicles, bumps that hair follicle, that hair follicle receptor will know and will let you know that there's a bug on you and you need to run. Okay, maybe not run, but do something about it. Okay. These guys, these free nerve endings, they literally are just hanging out. They're free. Nothing's stopping them, nothing's holding them, which differs from our encapsulated nerve endings, because our encapsulated nerve endings are locked up in some connective tissue. A lot of the time, those encapsulated nerve endings are going to be mechanoreceptors, and there are four main types of those mechanoreceptors. Meissner's corpuscles, lamellar corpuscles, bulbous corpuscles, and proprioceptors. Proprioceptors then gets broken down into 3 subdivisions as well. You generally just need to know that these exist. And then on the very next slide here, all of their functions, locations, stimuli is listed. Okay. Those Meissner's corpuscles, they are good at discriminating touch and vibration, low frequency vibration. Instead of rewriting them, I'm just going to highlight, save myself some time. Discriminating touch, low frequency vibration. Your lamellar corpuscles, they handle deep pressure, stretch, high vibration frequencies. And then your bulbous corpuscles, also deep pressure and stretch, but these guys do not adapt, or they adapt very slowly. Okay. The lamellar corpuscles, actually, let's start with tactile since they're there. There are spiraling nerve endings surrounded by Schwann cells, usually in the dermal papillae, rapid receptors for discriminative touch. You're going to see them in sensitive hairless areas. The lamellar corpuscles are a single nerve ending surrounded by layers of Schwann cells. Again, you're going to see them in the subcutaneous tissue, and they're sensitive to deep pressure and rapidly adapting. And then your bulbous corpuscles, they're in the dermis. They respond to pressure, and they monitor continuous pressure on the skin. Cool? And then you've got your proprioceptors. 3 types of proprioceptors: your muscle spindles, your tendon organs, and then your joint kinesthetic receptors. Okay. Muscle spindles help to measure the changing length of a muscle. You're going to find these embedded in the paramecium. And they have these things called intrafusal fibers. Intrafusal fibers are just modified skeletal fibers that are inside these muscle spindles. Okay. Tendon organs are going to monitor stretch of your tendons. And then those joint kinesthetic receptors are going to monitor the joint capsules of your synovial joints. Okay. They're going to have mechanoreceptors and nociceptors so that you can't overstretch a ligament or a joint or something like that. Cool? Cool. This is just a visual of the words that I just said. Have your muscle fiber, your intrafusal muscle fibers, as well as some extrafusal muscle fibers. But those intrafusal muscle fibers are deeper within. Questions? Sick. Cranial nerves. We know about those. They exist. They may be cranial, but they are technically a part of your peripheral nervous system. They attach to the brain and pass through some very specific foramina in the skull. You have 12 of them, and they are numbered 1 through 12. Cranial nerves 1 and 2 attach to the forebrain. All of the others, so 3 through 12, will attach to your brainstem somewhere. Most of your cranial nerves are going to serve your head and your neck. They're going to provide sensory or motor function, depends. But your vagus nerve is the only one that will travel into your abdomen. Okay? For that, you gotta remember, if you're going to Vegas, you must wander. Your vagus nerve is also known as your wandering nerve. Going to Vegas, you will wander. Your vagus nerve, it does wander. It does not go, nope, it does go to your abdomen. It goes all over the place. That boy wild. Okay? These are your cranial nerves. Here is where you will find them. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nope, flipped them. 11, 12. You can't see those teeny tiny little numbers that I put up there, but they're there. Okay? Do you remember our mnemonic for the cranial nerves? Let's pause. Those are all 12 of your cranial nerves. I said just a little bit ago that the majority of your cranial nerves are going to serve your head and your neck. They serve sometimes sensory innervation, sometimes it is motor innervation. In order for you to know which is which, I have another fun mnemonic for you. Okay? So, O, 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 E, A, 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 right? That is the cranial nerve. And to know whether it is sensory, it is a sensory nerve, a motor nerve, or a both nerve. Sick. Okay. So this next graph has your cranial nerves and then what they do and general things like that. I do want you to know general function. Truly, you do not need to know any more than what is shown on this page. Okay? you need to know that olfactory is smelling, optic is for vision, ocular motor is going to help move your eyeballs, trochlear, all you need is this. Cool? Cool. The rest, well, at least a large portion of this presentation is going to go through the cranial nerves in more detail. And they are all listed for you here. Where you'd find them, their origin, the pathway that they take. So this is olfactory, optic, oculomotor. I do want you guys to go through this. I'm not expecting you to memorize every bit of detail on these pages. Okay. Trochlear, trigeminal. The trigeminal nerve has 3 divisions: the ophthalmic, the maxillary, and the mandibular. You remember this thing that I did? Ophthalmic, maxillary, mandibular. Right. Abducens also kind of helps move your eyes. Facial nerve has 5 branches to it. It's this way, like that, I think. Don't worry, you're gonna see the thing with the kid on his face. And generally where those branches are. So you have a temporal branch, a zygomatic branch, a buccal branch, a mandibular branch, and a cervical branch. Cool? Cool. And then the rest of them. Just go through these so that you know what they are and very generally what they do. Okay? In our peripheral nervous system, we also have spinal nerves. There are 31 pairs of spinal nerves, and they're going to connect directly to your spinal cord. Okay? They are named for the point of where they exit the spinal cord. Okay? You have 8 pairs of 8 pairs of cervical nerves, 12 pairs of thoracic nerves, 5 pairs of lumbar nerves, 5 pairs of sacral nerves, and 1 pair of coccygeal nerves. A lot of the time, these spinal nerves will make nerve plexes. I'm sure you guys have heard of like your brachial plexus or your lumbar plexus, and that is formed by these spinal nerves. Okay, so you have a cervical plexus, you've got your brachial plexus, you've got your lumbar and thoracic plexus, lumbar and sacral plexus, and then just that one large coccygeal nerve. Okay, this next slide is going to look overwhelming. Don't freak out. Okay. Spinal nerves connect to the spinal cord by the dorsal root and the ventral root. Let me show you that. So, the dorsal root and the ventral root. I should actually probably do these in different colors, but that's okay. Okay? The dorsal root is going to contain sensory fibers. And the cell bodies of those fibers are going to be located in the dorsal root ganglion. What is a ganglia again? A ramus is a bridge, right? Rami means bridge. Okay, so you will have a dorsal bridge and a ventral bridge. Okay, the dorsal and ventral rami contain both sensory and motor fibers. Let's follow that up in blue. Ventral ramus, dorsal ramus. Okay, and the rami communicantes will connect the ventral ramus to the sympathetic trunk ganglia. The sympathetic trunk ganglia is going to be where a lot of your sympathetic nerves are going to synapse with their postganglionic neuron. That'll make sense in a second. Okay? So, some vocab words that you need to know. Dorsal root, ventral root. Dorsal ramus, ventral ramus. Rami communicantes, sympathetic chain ganglia. Spinal nerve. The spinal nerve will have both motor and sensory fibers running through it. Cool? There it is. Some visual for you. Okay? So remember, sensory information is it going towards my central nervous system or away from my central nervous system? Sensory information. Seek. Your back is going to be innervated by those dorsal rami. Relatively neat, relatively organized. Your anterior thoracic and abdominal walls are going to be innervated by your ventral rami and your intercostal nerves. You hear intercostal, what are you thinking? Between, for sure. Between your ribs. So your between rib nerves, okay? Those intercostal nerves are going to supply your intercostal muscles, so your internal and external intercostal muscles, your skin, and your abdominal wall. And then each of those intercostal nerves is going to branch and make a lateral and anterior cutaneous branch. Cutaneous just means to the skin. Okay? And that's kind of what that breakdown looks like. Communicantes, you have your spinal nerve itself, you have the dorsal ramus going to your back, your ventral ramus coming up to the front. Cool? Cool. Nerve plexuses, you've got several. Your nerve plexes are generally due to the ventral rami kind of joining together. They will branch, join one another, and make these several different nerve plexes that control different areas of your body. Okay? Except for the ones in T2 to T12, these ones are going to your ribs. Specific. What? Nice. Cool. Your cervical plexus, first one, it is deep to your sternocleidomastoid muscle. As you know, that one's one of my favorites. That sternocleidomastoid goes right along here. That cervical plexus sits just deep to it. Okay? Most of your cervical plexus nerves are cutaneous nerves, so most of them are going to go to your skin. but some of them are going to innervate the muscles of the front of your neck. Okay. They are formed by your first 4 cervical nerves, C1 through C4. This you will need to know. Okay. Of your cervical plexus, the most important of those nerves is the phrenic nerve. It innervates the diaphragm. Your diaphragm is your main muscle of breathing. It is the prime mover of breathing. There's a little quip that people say, 3, 4, 5 keeps the diaphragm alive. That's cervical nerves, 3, 4, and 5, that make up the phrenic nerve that keep your diaphragm alive. If that phrenic nerve gets cut, gets damaged, something happens to it, you will stop breathing. Period. Okay? 3, 4, 5 keeps the diaphragm alive. Cool? Your brachial plexus, a little bit more complicated. It lies in your neck and axilla. Where's the axilla? Your armpit. Right. And it is formed by the ventral rami of C5 through C8. But wait, we only have 7 cervical vertebrae. How do we have a C8? Right, because we name the cervical nerves based on the bone that is above it, right? So C1 is actually, the C1 bone will sit right here, right? There you go. C1 nerve is up here. C2, C3, C4, 5, 6, 7, 8. So C8 is just the guy that is right on top of your C7 bone, if that makes sense. Okay. The cords of your brachial plexus give rise to the nerves of your upper limb. And the components of that brachial plexus are the ventral rami. Those guys are going to come directly from the spinal cord themselves. They'll form the roots of that brachial plexus. Those ventral rami will merge to form trunks. Those trunks will split into 2 divisions, anterior and posterior. And then each division will form 3 cords. And I'll show you what that visually looks like on the next slide. Vocab words that you should know. There you go. Trunks, divisions, cords. And I would know that the trunks are divide into anterior and posterior. What does that mean? It means this. So you'll have your roots, the ventral rami from C5, C6, C7, C8, and T1. They will merge together. So C5 and C6 merge together and form your upper trunk, your upper nerve. I'll go upper trunk. C7 does not share. That's fully your middle. C8 and T1, they merge together and form the lower. Those trunks split into divisions, an anterior and posterior, anterior, posterior, anterior, posterior, and then those divisions will make cords. So your upper anterior and your middle anterior will form your lateral cord. Your upper posterior, your middle posterior, and your lower posterior will form your posterior cord. And then your lower anterior will form your medial cord. Those cords will then branch again and form the terminal branches of your nerves. So your lateral nerve and your lateral nerve will form your musculocutaneous nerve. Part of your lateral and part of your medial will form your median nerve. Part of your medial will form your ulnar nerve, and then your posterior nerve forms your radial and axillary nerves. This is a summary of this information. Here is the nitty-gritty of that information. You can see all that stuff leaving. This is roots, trunks, divisions, cords, and then on this guy, you can see all of those nerves themselves. Okay. There's all that information about those nerves. I would know their names. I definitely know their names. And I would know what they originate from. Axillary is part of the posterior cord. Okay. Cool. This next slide just shows you those different nerves. So the musculocutaneous nerve, and then a couple of the muscles that it innervates. The median nerve, some of the muscles that it innervates. The ulnar nerve, some of the muscles that it innervates. And then the cutaneous innervation, again, cutaneous just means to the skin. So you can see how each of these nerves is affecting what areas of your skin. And then radial and axillary nerve as well. Okay. In your lower body, you have the lumbar plexus that arises from L1 to L4. Some of the smaller branches of your lumbar plexus will innervate your posterior abdominal wall and the psoas muscles. You have technically two psoas. You have psoas major and psoas minor. But the main branches of the lumbar plexus are going to innervate your anterior thigh, and they will be your femoral nerve and your obturator nerve. This is obturator. This big old guy here is your femoral nerve. Okay. And then your sacral plexus. Your sacral plexus arises from L4 to S4. We kind of usually end up grouping it with the lumbar plexus because the lumbar plexus is so small without it. A couple of the nerves that you need to know in this lumbrosacral plexus. the sciatic nerve. I'm sure you've heard people say, oh, my sciatica has been acting up, right? And it kind of feels, I don't know if any of y'all are old enough to have sciatica pain, but that thing hurts. It hurts from like your lower back all the way down to like, hell, dude, your calf, maybe a little lower. The ones that know, if you know, you know. I can see you nodding at your head with me. So if you know, you know. Okay. That sciatic nerve is actually two nerves in one sheath. It is the tibial nerve and the common fibular nerve. Okay. That tibial nerve branches, so it has two parts to it. The median and lateral plantar nerves. The common fibular nerve also branches, becomes the superficial and deep fibular nerve. And then you have a couple of extras that are hanging out, your superior and inferior gluteal nerves and your pudendal nerve. All of these nerves are part of your brachial plexus. Not brachial plexus, sorry, sacral plexus. Okay. Cool. There it is, that sacral plexus. There's a lot going on there. All I need you to know is the names of the nerves that are involved in this sacral plexus. Okay. And here's that view of it with the muscles that it innervates and then some of the cutaneous innervation. So you can see if you touch kind of the internal thigh, you are activating the obturator nerve, things like that. And then some of the muscles that they innervate as well. We spoke very briefly about the skin being innervated. We have a special name for areas of the skin. It's called a dermatome. A dermatome is, well, we have what we call like kind of dermatome maps, which just show what area of the body is innervated by what spinal nerve. Okay. Most of your upper limb, the skin, is supplied by nerves of your brachial plexus. Your lower limb is going to be your lumbar nerves and your sacral nerves that innervate your anterior skin and posterior skin, respectively. And then here is that dermatome map, front and back. So you can see that, this upper part of the chest here, this like kind of lower shoulder, is innervated by your C5 spinal nerve. Your pinky, C8. Does that make sense? So this map of dermatomes kind of helps us to understand where in the skin each spinal nerve is innervating. Cool?